Now let's look at compound and inequalities. To be a solution to an and inequality, x must make both of the individual inequalities true. In this first example, to be a solution, x has to be greater than -1, and x also has to be less than or equal to 4. Before we move on, let me point out that this is how we actually write and compound inequalities, and not using the word and. The way this notation is derived is this first inequality is rewritten with the constant on the left. So x is greater than -1 is equivalent to -1 is less than x. We take that inequality and that forms the left part of our compound inequality notation. The right part just states x is less than or equal to 4. This is some notation that you'll get used to, but just know compound and inequalities are not actually written with the word and. In order to understand the graph of -1 is less than x is less than or equal to 4, I'm going to go ahead and graph each of those individual inequalities. So first I'm going to graph x is greater than -1. X is greater than -1. That's going to have an open dot at -1 and an arrow pointing to the right, indicating the values of x greater than -1. The right-hand side is going to have a closed dot at 4. X is less than or equal to 4 includes 4 as a solution, and then an arrow to the left indicating x can be any value less than 4 as well. Now this is not my graph of my compound inequality. This is not the graph of x is greater than -1 and x is less than or equal to 4, which we write as -1 is less than x is less than or equal to 4. In order to be in the solution set to this compound inequality, x must satisfy both of those inequalities. This orange part right here does not satisfy both. This orange part only satisfies x is greater than -1. It does not satisfy x is less than or equal to 4. This purple part only satisfies x is less than or equal to 4. It does not satisfy x is greater than -1. Therefore, my actual graph will be the overlapping region of the two individual inequalities. So the part that makes both of the inequalities true, all the points that are in both solution sets. 4 is in my solution as well. 4 is less than or equal to 4 and greater than -1. -1 is not in my solution set, so that's an open dot. Again, the purple and the orange help me understand how I got the graph, but my actual graph of this compound inequality is just the blue part. This is one way where this notation is really helpful because I can just graph my compound inequality graph straight from this notation. My left boundary point will be this -1, and I will determine open or close based on that inequality symbol. Since I don't have an equal sign, I'll just do an open dot at -1. My right boundary point will be at 4, determined by this inequality symbol. I'll have a closed dot because 4 is in my solution set. Now since this is an and, x is between these two values, not including -1, but including 4, I just shade in between. Just like OR graphs always look like two arrows pointing out, and graphs are always two boundary points connected in the middle. Possible solutions to this and inequality are 0, 1, 3, 4, but not -1, and not any value less than -1, and not any value greater than 4. So just the numbers between -1 and 4, including 4. Let's go ahead and look at some situations. And situations are a little trickier, whereas or situations pretty much always use the word or, and situations don't. One word that's often used in an and situation is but. So this situation, using the word but, is an and compound inequality. The recipe calls for you to cook the dough for at least 16 minutes, but for less than 20. So at least 16 and less than 20 sounds weird. We use the word but. At least 16 minutes means 16 minutes or more. At least 16 is x is greater than or equal to 16. 16 minutes, 17 minutes, 18 minutes. But for less than 20, x is less than 20. So we can't cook the dough for 21 minutes or 22 minutes. We cannot write our compound inequality like this using the word and. we have to rewrite it in our notation with a constant on the left-hand side. So I'm going to write this as 16 is less than or equal to x is less than 20. This tells me x is greater than or equal to 16 and x is less than 20. I can graph straight from here. So 16 and 20, you don't have to include the scale, just include the two boundary values. Close dot at 16 because 16 is okay. Open dot at 20 because 20 is not okay. And I'm shading in between. This is what every compound and inequality graph looks like. Possible solutions are 16, 17, 19, not 20, not 21, not 22. Last example is a little controversial. You are going to spend between $40 and $60 on a new pair of shoes. Now between is definitely an and, but in earlier math classes you were taught that between did not include the maximum or the minimum, the two boundary values. You were taught that between would be written like this. 40 is less than x is less than 60. Sometimes that may be correct with the word between, but if we think about this situation, if you told me, I'm going to spend between $40 and $60, I think you'd agree that you mean you might spend $40 or you might spend $60. You don't mean, oh, I only am going to spend $40.01 up to $59.99. Just be ready to justify if you're including the equal sign or not. I'm going to say here that I'm including the equal sign. If I tell you I'm spending between $40 and $60, that can include 40 or 60. That means I'm going to represent this with a closed dot. And then just like every and inequality graph, I'm connecting those two boundary points. Possible solutions here are 40, 45, 59, 60, but you cannot spend $61, you can't spend $39. You need to spend somewhere in between, and I'm going to say it's okay to spend 40 or 60.